Warahmatullahi wabarakatuh, and hi everyone. In this video I want to summarize about gas law. Okay, in subtopic 5.1 we learn about Boyle's law. So Boyle's law is the relationship between pressure and volume. So pressure is inversely proportional to the volume at constant temperature and pressure. So the formula used for Boyle's law is P1 V1 equal to P2 V2. And then we have Charles' law, where volume is directly proportional to the absolute temperature at constant pressure and number of mole. Therefore, the formula used for Charles' law is V1 over T1 equal to V2 over T2. And always remember that the temperature used is absolute temperature, means you need to convert the temperature to unit Kelvin. Okay, and then we have Avogadro's law, where the volume is directly proportional to the number of mole at constant pressure and temperature. Therefore, the formula used for Avogadro's law is V1 over N1 equal to V2 over N2. Okay, and then from this law we get ideal gas equation where PV equal to nRT. So P is pressure, V is volume, N is number of mole, R is gas constant, and T is absolute temperature. So when we substitute the formula of number of mole equal to mass over molar mass, okay, we get PV equal to M over MR RT. Okay, and then we rearrange the formula, then we get P MR equal to M over V times RT. Okay, so M over V is actually density, so we substitute M over V equals density, so we get density rho equal to PMR over RT. Okay, so to do calculation using ideal gas equation, you always need to make sure that the R used, the gas constant used, is correct. Okay, we have three values of gas constant. The first one is 0.08206 atm liter per mole per Kelvin. This is the unit for gas constant for 0.08206. So to use this value, you need to make sure that the pressure used in the calculation is in atm and the volume used is in liter. Okay, so for the second gas constant, 8.314 Newton meter per mole per Kelvin. Okay, you always have to make sure that the pressure used is in Pascal or Newton per meter squared. Okay, and the volume is in meter cube. And the last one is 62.36 millimeter mercury liter per mole per Kelvin. Okay, for this value of gas constant, you need to make sure that the pressure used is in millimeter mercury or torr, and the volume is in liter. Okay, so and the last one we have Dalton's law, Dalton's law of partial pressure. So if we have a mixture of three gases A, B and C, the total pressure of the gas in the container is equal to the sum of the partial pressure of each gas. Okay, so we use the formula P total equal to partial pressure of A plus partial pressure of B plus partial pressure of C. Okay, and then we have another formula where PA or partial pressure of A is equal to mole fraction of A times P total. So XA is mole fraction. So mole fraction means the number of mole of A over number of mole total. Okay, if the question asks you to calculate the mole fraction, so we can use this formula. Okay, or we want to calculate the partial pressure and we have the number of mole of each gases, we can use this formula. Okay, and then if the question mentioned about a water displacement method, okay, you need to remember that the gas is collected over water. So if we use water displacement method, the gas collected is actually a mixture of gas and water vapor. So we need to consider the pressure of water here, P water. So the pressure given in the question is actually P total. So to calculate the P gas, we need to minus a P total with P H2O. Okay, that's all. Thank you.